Good day, ladies and gentlemen. In this key points video, we're going to be looking at some of the more difficult questions that get asked related to number systems. The first question is, how many bits are required to store a number? The second question is, how many different numbers can you store with a given number of bits? And the third question is, what's the highest value you can store with a given number of bits? Now, before you attempt these questions, you will need to understand how to convert between denary and binary. And if you're not sure how to do that, there's a link below. So let's take a look at the first question. How many bits are required to store a number? To answer this question, we just follow this process. Number one, we convert the number from denary to binary. Number two, we ensure that we don't have any leading zeros. Number three, we count how many bits are actually required. For example, how many bits are required to store the number 5? Well, using our binary, we can see that if I convert denary 5 to binary, it becomes 0101 in a 4-bit format. However, the first 0 is leading, so we can remove it. So we are left with 101. Now we can simply count the bits, which in this case is 3. So we need 3 bits to store the denary number 5. Now I'd like you to pause the video and answer these questions. So the first question, how many bits are required to store denary 10? Let's convert 10 to binary and we see that we have 1010. There are no leading zeros, so we can just start counting the bits. In this case, we need 4 bits to store the number 10. To convert the number 20, we can see that we need more than our usual 4 bits. So we'll add another bit at the start. This will be the 16s column. And now when we convert 20 to binary, we get the number 10100. And again, there are no leading zeros, so we can just start counting. And in this case, we need 5 bits. Next question is, how many different numbers can we store with a given number of bits? And this can be answered using the formula different numbers equals 2 to the power of bits. So if we have a 4-bit number, we can store 2 to the power of 4 different numbers. 2 to the power of 4 is 16, so we can store 16 different numbers. Now pause the video and answer these questions. So to begin with 12 bits, we can store 2 to the power of 12 different numbers. That's 4096. With 16 bits, we can store 2 to the power of 16 different numbers. That's 65,536 different numbers. And with 24 bits, we can store 2 to the power of 24 different numbers. That's 16,777,216 different numbers. The final question is, what's the highest denary number we can store with a given number of bits? And to answer this question, we can use this formula. The highest value is 2 to the power of number of bits minus 1. So we minus 1 because in computing, we always start counting at 0 instead of 1. So with 16 different numbers, that means we would start at 0 to 15 instead of 1 to 16. Now pause the video and answer these questions. With 4 bits, the highest number is 2 to the power of 4 minus 1, which is 15. With 8 bits, the highest number is 2 to the power of 8 minus 1, which is 255. So hopefully, you're now in a position where you can answer the most difficult questions on number systems. But of course, if you have any confusion, please don't hesitate to contact me. And as always, I look forward to seeing you soon. Take care.